Okay, guys, in chapter 18, section 1, we talk about the chemical equilibrium. We talk about the chemical reaction that could work in two opposite directions. That mean a reaction that happen in both directions, as this reaction, for example, nitrogen reacts with hydrogen to produce ammonia. So this is a reversible reaction, or that is an equilibrium. It would means the reactants react together to produce the product, then the product is going to dissociate or break down or react to produce the reactants one more time. So we talk about the equilibrium reaction in details in the first section. In that section, we start to talk about the shifting the equilibrium. That means if I have a chemical equation or a chemical reaction which is already equilibrium is established, or we have a reversible reaction, how we could shift this equilibrium. That means could I activate the rate, okay, of the reactants on products? That means I make the reaction lies to the right direction or the left direction about some changes. So we said that there are some factors that could change the equilibrium or shift the equilibrium, like change in temperature, change in concentration, change in pressure. And we explained this in details in the last videos. Okay, so please check your channel on the YouTube to study the old videos and find this point. Today we're going to pass to another part here. We said that we're going to talk about the reaction that go to completion. What do you mean by reaction that go to completion? Actually, some reactions, or we said that here in some reactions, the reaction happen in the ionic compounds, or that there are some ions in that reaction. So these ions or this reaction, what happened? The ions may be completely combined to each other or attract to each other, and they become hardly to dissolve or hardly to break down. So in that kind of this reaction, one of the products, okay, or one of the results of the reaction will escape or will not be available or will not be part of the reaction anymore. That will cause a reversible reaction or cause the equilibrium to be disturbed, or there is no equilibrium, and in that case the reaction just will flow in one direction only. Let's understand this part here. For example, gas formation. For example, here once there is strong acid, and this strong acid is added to bicarbonate. Of course, this equation is not complete. We just this equation will just resemble the ions, but we don't represent. For example, here H3O, that the hydronium ion which is produced from acid. For example, that suppose if you get HCl and you dissolve the HCl in water, so what would happen in that case? Actually, HCl will dissociate in water, producing hydrogen ions and chlorine ions. So these hydrogen ions will combine with water to form the hydronium ion, and the chlorine ions will be free. So we don't care about the chlorine ions now, okay? We just here get the effect, because the effect of acid based on the free hydrogen proton that will combine with water to form the hydronium. So once we said that H3O positive, that the hydronium ion which is produced due to the dissociation of or breaking down of strong acids. So here that's hydronium. HCO3, that the bicarbonate ion, for example, of course it cannot be found free, but for example NaCHCO3, that sodium bicarbonate, that is a compound. Once this compound dissociates in water, it will produce positive sodium and negative bicarbonate ion. So we just care about these two, that they are gonna, okay, that's the part which is important in the reaction. So somehow we cancel or remove Na and Cl. They are not mentioned in the equation. The purpose or the idea here, once the hydronium ion is gonna react with the bicarbonate ion, what would happen in that case? Simply, okay, we're gonna find that they will produce water and carbon dioxide. Carbon dioxide actually is a gas, and this gas, of course, will come out from the tube. So in that case, that means gas is already get out. So the carbon dioxide is not able to react anymore with water to move in the opposite direction. So in that case, this reaction will keep moving in one direction only. It will not be a reversible reaction. Why? Because one of the products already escaped. It's not involved in the reaction anymore. So in that case here, we will find that the reaction is working or moving in one direction, that's from forming the carbon dioxide and water, in which all the hydronium ions will completely react with all the bicarbonate ions to produce water and carbon dioxide gas. Is it clear this part, guys? Guys, is that clear?
Yes, Master.
Okay. So another example here, we said that the formation of precipitation. Okay, precipitation, that means a formation if we have two aqueous solutions. Okay, that means two solutions are reacting together and they produce a solid. This solid precipitate or settle down at the bottom of the tube. Like for example, when we have sodium chloride, NaCl, that sodium chloride. Why we wrote it as Na positive, Cl negative? Because as an aqueous solution, Aq, it means aqueous solution. So actually, when we put sodium chloride, the table salt in water, what would happen? It will dissociate into positive ions and chlorine ions. So we just wrote it in form of ions to represent you what is gonna found inside the beaker. Okay. So for example here, when we get sodium chloride, Na positive and Cl negative, they are ions, and the silver nitrate, Ag positive and NO3 negative. Okay, so these ions now are found in the beaker. What would happen? Actually, we're gonna find that the sodium will combine with the nitrate and the silver will combine with chlorine. So it will produce silver chloride and sodium nitrate. But unfortunately here, or that's what we're gonna find, that the sodium nitrate is easily dissociate or break down into ions. So they are gonna still as ions in water, okay? But once silver combined with chlorine, it produces silver chloride, which is solid, and this solid is hardly dissolve or hardly break down, hardly dissociate. That means it will not break down. So this silver chloride will settle down at the bottom of the tube, and in this case this is not more ions. Okay, it become a compound. That means silver ions and chlorine ions now are excluded from the reaction, so they will not react anymore. In that case, all the reaction will move in that direction only, because absence of silver and the chlorine ions will not allow the reversible reaction. So like this, okay, also this reaction tend to be a complete reaction, or this reaction just will flow in one direction only, which is the right direction or the forward direction. Okay, so like this here, that represent what how that could affect, or how, okay, the absence of some ions, they could affect the reaction or make the reaction just flow in one direction only. Also here, a slightly or formation of a slightly ionized product. For example, here when we get a strong acid like hydrochloric acid HCl, once it dissolved in water, as we said before, the hydrogen which is released from the hydrochloric acid will combine with water forming hydronium ion. So the hydronium ion and the chlorine ion, they are free. That is the aqueous solution of hydrochloric acid. And we have here, for example, the sodium hydroxide. Okay, that is a base, so that is acid and base. It's a neutralization reaction. So also hydroxide or sodium hydroxide in aqueous solution will dissociate into sodium, okay, ions, which are positive, and the negative hydroxide ions. So what would happen in that case? Simply, we're going to find that the sodium will combine with chlorine, forming sodium chloride. Sodium chloride is easily dissociated, or it's that salt that easily could break down into ions in the aqueous solution. So they still found as ions. Okay, while we are gonna find that the hydronium ion will combine with hydroxide ion to produce two molecules of water. Water is a slightly ionized product. That means the water actually does not break down into ions easily. So we are gonna find the water found in form of molecule, a liquid molecule. That means is not involved anymore in the reaction. So also that will not allow the reverse reaction, and that will make the reaction just complete its path in one direction to the right direction and to the direction of forming the product. Okay. So here that the idea, guys, or that the main idea of this part. So just to clarify this idea for you, okay, I need you, okay, to watch. Okay, just so we are going to explain this part first, then we watch the video. So here like this, the purpose or that the main idea of these three examples, gas formation and formation of precipitate and the formation of slightly ionized products, that some reactions, the products, okay, will not be involved anymore in the reaction. That means they somehow will be isolated, whatever they are solid and they will not react, whatever they are liquid and they cannot be ionized, or whatever it's a gas and escaped out of the tube. So once there is a particle, or once there is a product is already escaped from that tube, that will not allow the reversible reaction, or won't allow a reaction to move backward or to work in the reverse direction, which means the reaction just will flow in one direction, and we call that the reaction tended to go to completion, or the reaction will complete in one way. Then here we talk about the common ion effect. What is common ion effect? Actually, this is very brilliant, and I did one here. So regarding to the Le Chatelier principle, which we explained in the last session, okay, which said that in case of equilibrium, once we have a reaction in equilibrium, so the reaction, and then the reaction become under stress. We said that stress means changing one of the conditions of the reaction. The reaction will start to be activated in the direction that relieve the stress or cancel this stress. So what would happen here, or what this case, what we should do? So we said that, for example, if we have NaCl, that is sodium chloride, and we dissolve sodium chloride in water, so actually the sodium chloride will dissociate into positive sodium ions and negative chlorine ions. And in that case, we are going to reach the equilibrium. And that will not happen until we get a saturated solution. Because as we know, in saturated solution, that means the rate of dissolving equal the rate of crystallizing, as we explained in the last quarter. So once we have a saturated solution of NaCl, we reach the equilibrium state in which the amount of dissolved sodium chloride equal the amount of sodium ions that are going to react with chlorine ions to crystallize and forming new sodium chloride crystals. So once they are in saturated solution and reach this equilibrium, can we make formation, or can we change this equilibrium or shift this equilibrium? Actually, that would be hard. That's by normal conditions. It will be hard, but we have a certain thing here. What would happen if we add hydrochloric acid to this beaker? That means, let's just draw it to understand here. If I got a beaker, this beaker contains saturated solution of NaCl. So this NaCl we added here in the bottom. So some NaCl dissolved, and in the same time, some NaCl dissolved, another will crystallize. So like this, we call this is a saturated solution. So like this, we are gonna find that the concentration of sodium chloride as compound or as a crystals equal to the concentration of sodium ions and coloration of chlorine ions. All that already found in the beaker. What would happen if we add hydrochloric acid? So simply the hydrochloric acid, we said that once we add hydrochloric acid in water, it will dissociate into, it will break down into hydrogen ions and chlorine ions. So in that case, we're gonna have extra chlorine ions in solution, which means, now we get more chlorine, already the chlorine which is already produced from the sodium chloride and the chlorine which is produced from the hydrochloric acid. So like this, the concentration of chlorine become more, so which means this concentration increases. So as this concentration or the concentration of chlorine increases, that considered as a stress in that equilibrium, because in equilibrium the two sides must be equal. So like this here, once we increase the the chlorine ions concentration, that considered as a stress. So regarding to the Le Chatelier principle, the reaction will work in that direction to cancel this stress. That means the reaction will be activated to the left direction, in which combine more chlorine ions with sodium ions to produce NaCl, or to produce more NaCl in that case, to relieve this stress. So in that case, we allowed, or we just activated the one side of the reversible reaction by using the concentration of ion that common between the two reactions. So we call this the common ion effect. Is it clear here, guys? Is it clear this part? Guys, is that clear?
Yes, Mister.
Okay, I need you to watch this video, okay? So like this, guys, that's the point, which is known as the common ion effect. That means we use a soluble compound that contain ion, which is already the same ion that involved in the equilibrium reaction, to just shift the reaction into another way. So here, like this, guys, that's the idea of our lesson, and by this part we end our section. So I hope to read it carefully through your textbook and watching the videos one more time to understand this part, and to be able to answer the questions. You are gonna find the SMS, the presentation is already uploaded, and also you're gonna find there is worksheet 1 that cover, or the questions cover both section 1 and section 2, and also you are need to, or you're supposed to answer the section review of the first section and the second section. Any other question, guys, here? Guys, any hard
No,
question?
thank you. No,
So
no.
please, guys, okay, try to be up to date. Okay, I know that you were somehow you are busy because of the ACT trial and so on, but now please try to just make kind of backup for what you missed. Okay, so them will use this week. Okay, especially the weekend. Okay, just to cover all the points. And if there is any part is not clear or you cannot understand or some questions you want okay to ask, I am available all the time. Send to me your questions, whatever during our online sessions or even through the WhatsApp, and I'm gonna answer you inshallah. Okay, guys. Thank you, guys, and
Okay.
goodbye.